What's up, math ninjas? Mr. Antonucci here. And in this video today, I want to talk about how to differentiate the exponential function e to the x. So let's check out some rules here to get started, and then we'll walk through a couple quick examples. So if you have a function e to the x, the derivative f prime is, guess what? Itself. This is one of the unique properties of the exponential function e to the x, is it is its own derivative. Now, if you had e to the u, where u is a function, so let's say u is some function, other equation, some function of x, then the derivative, applying the chain rule, is the derivative, or excuse me, is e to the u times the derivative of whatever u is. Usually, you write that as u prime e to the u, and that's how I'm going to refer to it, u prime e to the u. And that's really what you want to remember. You want to remember that chain rule. So the first example is if we have y equals e to the 2x, straightforward example here. The u is the 2 to the x right here. And so u prime would end up being 2. So it'd be e to the 2x times 2, which would be 2e to the 2x. Don't multiply the 2's in the exponent and get 4x or something like that, okay? Very straightforward here. U prime e to the u, 2e to the 2x. How about this one? If you had y equals e to the x cubed. Don't let that scare you. The u here is what? Right, x cubed. So u prime is going to be 3x squared. So the derivative is going to be u prime, 3x squared, e to the u, e to the x cubed. And that's it. Pretty straightforward. Okay, I want to do two problems that involve other rules. First one, if we have y equals x e to the 3x, not only do you have an exponential here, but you're multiplying by x. And remember, you have to use the product rule when you're multiplying two functions together and trying to differentiate. One of the common mistakes I see is students learn the product rule, and then later in the year, they'll forget it, and they'll just do the derivative of each factor multiplied together. Like they would do the derivative of x is 1, the derivative of e to the 3x is 3e to the 3x, so they'd multiply that by the 1 and get the answer. No. We have to remember the product rule. Now, there are a number of ways that the product rule is written, depending on the textbook and your teacher and their preference. But as long as you have derivative of one factor times the original of the other, plus the reverse of that, you're fine. I like to teach it as the derivative of the first, which would be x, times the second, plus the first times the derivative of the second. Now, the derivative of e to the 3x is going to be u prime e to the u. And then if we just clean this up a little bit, notice both terms have a factor of e to the 3x. You could factor that out, and you would have 1 plus x. It's not necessary to factor that out. I forgot the 3 here. It's not necessary to factor out the e to the 3x, but sometimes that might be helpful later. For example, if you're doing max-min problems or application problems where you have to solve for where the derivative is equal 0. And I made a big boo-boo here. Got to have your y prime there to indicate that you're doing the derivative. And this is another thing that's very important, is I will often see students do problems like this and not be consistent or detailed with their notation. For example, sometimes students will just write equals. So you have the original problem equals, and then they'll start differentiating. But really, it's not equal, because what you're dealing with now is the derivative. And the notation is important, because if you think about another person looking at your work, the notation explains or indicates what is following. Okay, so that's important. All right, one more thing. Y equals e to the x squared over x. And again, quotient rule here, Same thing, don't just do the derivative of the top divided by the derivative of the bottom. Students learn the differentiation rules for the quotient rule, and it's important that you remember that and follow the quotient rule. So the quotient rule is more strict, if you will, on how it works, because it's always the denominator squared. And again, students often, one thing I think happens is students think or mistakenly think that the quotient rule is the same as the product rule, just with a subtraction sign, but it's not. A lot of times students will forget the denominator. So here's how it works. It's the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the denominator or the bottom squared. So derivative of the top is 2x e to the x squared times the bottom, which is x, minus the derivative of the bottom, 1, times the top, e to the x squared, all over the bottom squared. Now let's clean this up a little bit. That first term, those x's can multiply together to give you 2x squared e to the x squared minus, and 1 times e to the x squared is just e to the x squared, all over x squared. And if you wanted to get all fancy pants on this one, you could factor out an e to the x squared, but I will caution you, you cannot cancel this x squared with this x squared. You can only cancel factors in the numerator and denominator when it's multiplication. And I understand that you have multiplication here, but you also have subtraction. If you had products of quantities in the numerator, then maybe you could cancel. So if we factor out an e to the x squared, you would have 2x squared minus just 1 all over x squared. I'm running out of room there. Okay, but that's it. That's all the further you can go. So you still can't cancel out this x squared here with the denominator, so don't do that, okay? All right, guys, well, that's it for this one. I hope it was helpful to you. If you have a question you'd like me to go over, drop it in the comments and maybe I'll make a video about it. Make sure you subscribe to the channel. All right, take care.